This is the 2012 question 5 probability question. Company produces calculator batteries. The diameter of the battery is supposed to be 20 mil. The tolerance is 0.25 of 1 millimeter. Any batteries outside this tolerance are rejected. The company has a machine that produces batteries with diameters that are normally distributed. Taking our normal distribution curve here, with a mean of 20 and standard deviation 0.1. Out of every 10,000 batteries, how many are rejected? Okay, well, let's do a sketch hopefully to help us. Here's my normal distribution curve. I've got a mean here of 20 and standard deviation is equal to 0.1. The tolerance is 0.25. So if they're supposed to be 20 and the tolerance is 0.25, anything greater than 20.25 over here or less than 19.75 on the other side are going to be rejected. These guys in here and in here. So we're just testing the z-score for this much, and then we're doubling what it is over 50 to get both parts. So we're testing 20.25. You know your test statistic, x minus mu, sorry, not comma, x not supposed to be there. What we're testing against the average divided by standard deviation. So the average is 20 and the standard deviation 0.1. So we get 0.25 over 0.1, which is 25 over 10, which is 2.5. And if we look up a z-score of 2.5, it's going to give me very high here, 2.5 standard deviations, 9938. If we take 50 away from that, we're going to get 4938 is going to be in this section here, with the other 50 on the other side. So we have to double that. We have to double 0.4938. I don't know what that decimal's down there. We have to double 0.4938. And if we double that, we're going to get 9876, it looks like. 0.9876, right, that's what's in the middle, which leaves is it 124? 124. That's what gets rejected. 98.76% get kept. Now we're asked out of every 10,000, so 10,000 by 0.0124 is going to give me 124 rejects. Not too bad. Now what happens next? A setting on the machine slips so that we can create a leaving cert question. So that with the mean diameter of the battery increases, this is the mean increases to 20.05 while the standard deviation remains unchanged. Find the percentage increase in the rejection rate for batteries for this machine. So what we're looking at here is, so if we test 20.25 against 20.05 over 0.1, we're going to get 0.2 over 0.1, which is equal to 2. So that's thrown the symmetry off a bit, because what's happened here is, in the first case, we were off by, well, if we look at it, we were plus or minus 2.5 standard deviations. What's happened now is we're just plus 2. So it's shifted what's going on this way. So we were at minus 2.5, we're going to end up at minus 3 here. And you can see it's because we're testing 19.75 against 20.05 and dividing by 0.1, and we're going to get minus 0.3 over 0.1, which is my minus 3. So now I have to look up two different z-scores. Z-scores of 2, we can get this bit. The z-score of 3 will enable me to get this bit in here, and we can just add them together. So the probability that it's 2 and the probability that it's 3. Let's look at these two. So we look up a z-score of 2, we get 0.9772. 0.9772. So if we say, if we take 0.5 away from that, we're going to get 0. Now we don't have to do it this way, I'm just doing it this way today. Maybe just to entertain myself. So in there, there's 47%. Now a z-score of 3 is going to give me 0.9987. And if we take off again 0.5, it will tell us what's in here. That's going to be 0.4987. And if we add these two together, we're going to get what's in the middle, and then that will enable us quite easily to see what's in the tail. So it's just another way of visualizing these questions. There's quite a few ways to do these. So if we add these two numbers together, we're going to get 9, 7 and 8 is 15, 16 and 1 is 17, and we have a 9. So 1 minus 0.9759 will give me what's left in the tails. So you can see it's going to be, I'm going to have to add 41. Is it 241? No, that will give me what's left in the tails, 0.0241. And are we at the percentage change or something? Right, so the percentage increase. Okay, so what was it? It was, let's just double check what it was. It was 0.0124. It was 0.0124, and it's increased to this guy. So the increase is 117. 0.0117 is the increase, and it's over what it should have been, which is what it started at, 0.0124. So that's going to give me quite a high number. It's nearly doubled, hasn't it? It's just slightly under doubling. This is going to be 94.35%. So just a strange question bringing in percentage increase at the end there, but a nice little question, I think, and probably understanding what's going on, just the way they phrase the question, that you're not, getting stuck on something. Work your way through it, take your time, and these questions shouldn't pose too much difficulty.